All right, here we go. 3B.4, part B. We are going over formulas. Formulas means that the hard work has already been done. You just need to follow the process, okay? So if you have sine of two angles being added together, to calculate those values on the non-calculator part, I repeat, it would be on the non-calculator part. It wouldn't be on the calculator part because obviously you would just put it in the calculator, correct? So this would be on the non-calculator part, okay? It's just want to make sure it's going to be the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. So how I just remember SC plus CS. So I remember it. I don't make sounds for this. I really hate that I was transparent and vulnerable with y'all and y'all throw it back in my face.
What was the other?
It doesn't matter. Anyways, sine. We don't need to hear any of this. Please disregard my class as we continue learning things that I never said. So here we go. Differences. 22 days. 22 days. All right. 22 days. All right. Here we go. Subtraction is going to be the same, but in the middle, you are going to subtract. All right. I know, such a huge difference. Crazy. All right. Cosine. When the cosine rule is for sum and difference. Cosine, instead of it being an alternating the two, it's going to be the same. So it's going to be the cosine of the first angle times the cosine of the second angle minus, this is where it becomes the opposite. Cosine is your x. And remember how we said x's make things difficult and x's are liars? Yeah. Cosine, this is your x. Your x is lying to you. You think that you're going to add them, but you're actually doing what? Subtracting. Okay? Well, you're subtracting two angles and finding the cosine. What you're doing is going to actually be adding them. I'm being bullied by my class, and I would like to make that document. I'm not playing it. All right, here we go. Double angle. Double angle means that you have an angle, and it could either be represented. For example, if I had 60, it would be 2 times 30, right? Anything that's a double angle, the rule is 2 sine of the angle times cosine of the angle. It's just the rule you follow. Now, sine is friendly. Cosine is the one that they found all the different ways to find an equivalent value. This is before TV and technology. So I'm just saying, their brains were like, I feel like you're hating on them. Okay. Okay. So the first one is kind of similar to Pythagorean identity. Sometimes, a lot of times, students will mix it up with the Pythagorean identity, but it's not Pythagorean identity. It's cosine squared minus sine squared. And remember, when you're taking the difference, order matters, right? Okay. U just means unknown angle. Yeah. All are just unknown. If it bothers you, turn it to a theta, turn it to an x. It doesn't matter. It's just a variable. A double angle is like if I had 2 times theta. It's just, yeah, it's just an angle. We'll give an example. Okay. All right. Are we ready? These are the formulas we're going to be using. So up first, it says for us to find the exact value of sine of 5 pi over 12. Okay. Exact value means that we're using our unit circle. However, is 5 pi over 12 on our unit circle? No, it is not on our unit circle. But I can split it into parts. 5 pi over 6 is. Yeah, but that's not going to help us here. Am I? Okay. We're going to move from that. All right. 5 pi over 12. Jesus. So you got to find 2 angles on the unit circle that would make it that equal 5 pi over 12. So for example, I already did it for you, right? 5 pi over 12 would equal pi over 6 plus pi over 4. And we're going to follow the rule for sine. Okay? So if I have pi over 6 and pi over 4, we agree?
Yeah.
If you need me to explain, here it is. So that means you have, how can I put this in terms of a 12 with a denominator?
2 pi over 12.
It becomes 2 pi over 12 plus 3 pi over 12, which is why these are equivalent. Does that make sense? So now we're looking for the sine of, pi over 6 plus pi over 4. Yes. In order to solve this, we're following the formula. The formula for this, it's the sine of the first times the cosine of the second plus what? The cosine of the first times the sine of the second. So we're going to plug those in. So we have sine of pi over 6 times cosine of pi over 4 plus cosine of pi over 6 times sine of pi over 4. And again, you're using your unit circle. So on our unit circle, I'm going to draw a really quick little representation. If I'm at pi over 4, what are my ordered pairs? Square root of 2 over 2 and square root of 2 over 2. If I'm at pi over 6, right here, square root of 3 over 2 and 1/2. Okay, if by now you haven't figured out a little way of remembering the first quadrant, I'm going to show you mine. You can accept it or not. It's not anything weird. Everyone has a denominator of 2, correct? And so all I do, 1, 2, 3, 1, 2, 3, and I just put the radicals over non-ones. And that's how I remember quadrant 1. And as long as I know quadrant 1, then I know everything else. Okay, 1, 2, 3, 1, 2, 3, put my radicals. Okay, anyways, so now we're going to plug in their values. So sine of pi over 6 is what? Sine is your y. So what's the y value at 30? 1/2. What is the cosine of pi over 4? Square root of 2 over 2. What is the cosine of pi over 6? What is the sine of pi over 4? And now you're going to add. You cannot. 1 times square root of 2 is square root of 2. 2 times 2 is 4.
What do you put on the outside though? What do you like?
Actually, I think it has to be on the other side. Equals 0 now.
Yeah,
I was thinking.
it's just regular fractions. Multiply and add fractions like normal. Square root of 3 times square root of 2. Square root of 6. 2 times 2 is 4.
We can add the numerators.
So then my answer is square root of 2 plus square root of 6 over 4.
And we can't simplify that anymore.
I mean, you can rewrite it a different way, but it's not, there's nothing you can do to reduce it. Does that make sense? No, you cannot add radicals, you only can multiply. Yeah, unlike radicals, you cannot add. It's just like saying of X. Yeah, we kind of went through that really fast at the end of Algebra 2, but yes.
Yeah, I was like, I did not.
But yes. All right, so I was gonna have you guys do the example number 8. The bell's gonna ring in 2 minutes, so this is where we'll pick up on Friday. Got it? All right.